All right, much better. So we get an x value of approximately 4.265 years. But then the direction said to the nearest tenth. So let's try that again. 4.3 years. So almost done with the notes for today. You can skip question 3. The final thing I wanted to talk about was compound interest formulas. So we'll do 3 more problems together and then call it a day. For question number 4, you'll see that it talks about investing money into an account that earns 4% interest compounded monthly. And we want to find out how much money we have in 5 years. We're going to use the first formula for this, and we are going to say A equals. Now, technically, you could say N equals, doesn't matter. But just like before, we're going to sub in that 3,500, and then we're going to put the 1 plus, but we have to be careful. Yes, it is 4% interest, but it is compounded monthly, which means 12 times a year. Now, we're not getting 4% 12 times a year. We're getting a 12th of 4%. So then at the end of the year, that should total 4%. So you're going to take that interest rate and you're going to divide it by 12, representing the fact that you get a 12th of it every month. Now, we are going to collect interest for 5 years, but 12 times a year. So in the exponent, you have to do 12 times 5, which is equivalent to 60. Now, in your calculator, you are going to type in 3,500 and then 1 plus 0.04 divided by 12, and then you are going to raise that to the 60th power. We will get approximately $4,273.49. Now, another formula you learned in Algebra 2 with trig involves interest compounded continuously. Every time you have interest compounded continuously, you are going to use this formula right here. Now, how does this formula work? Just like the other one, you're going to say A equals that starting amount. But instead of putting 1 plus, we are going to put in E raised to the rate, 0.0375, times the time, which in this case is 7 years. I'm using the multiplication sign like that just so it doesn't look like a decimal. Now, in your calculator, you can type in 2,000, and then that E button is to the left of the 4, but we have to hit second and then that natural log button. And then we can type in the 0.0375 all times 7. Oops, don't need that. And you get a value of approximately 2,635 cents. Final problem for today is to talk about using our calculator to find the time it takes for something to happen again. In this case, we have this money that we're investing, 5% interest compounded quarterly. We want to find the time it takes for the investment to double. Well, first thing we need to think about is what's double 2,000, and that's 4,000. So when we set up our formula, we actually want to equal 4,000, and then we're going to fill in what was given. We're given that we start with 2,000, our interest rate is 0.05, but it's being compounded quarterly, which means we want a fourth of this every time we collect interest. Now, the time we don't know, but I do know that the time is representing years. So if it was 4 years, for example, we would do 4 times a year, which means we would have to take whatever the time is and multiply it by 4. So like we did before, I would like for you guys to go to your calculators and type this into y1 and this into y2. So we'll type in 4,000, and then down here, we will type in 2,000, and then 1 plus 0.05 divided by 4, all raised to the 4x power. Now, before you go to graph, go to your window. We should be fine with our x values, but with our y values, remember we want to see 4,000. So instead of going from 0 to 13,000, I'm just going to go 0 to 5,000 and then go to my graph. And again, if you don't see it, obviously we should see that y value, but if you don't see the intersection happen in this window, we can always change either x or y until we do in fact see that intersection. So it looks like it's almost there. At this point, we can do second calculate and then that intersect option. Enter, enter, enter. And we should get this value for t to be approximately 13.9 years. So that's it for today. I'd highly suggest you look at the Math Excel homework. At some point that will be due, so you do want to keep caught up with that.